So, I am going to discuss about the standard reduction potentials. So, in I have a half reaction. I have a table of half reactions here. So, which is having an element. So, standard reaction potentials reduction when you are in reduction, you are gaining of electrons. So, silver, it is an element. When it is gained with electron, turning into a solid silver, the standard reduction potential of the solid silver is 0.80 volts. So let's compare it with other element. Hydrogen gaining up of electrons, the standard reduction potential of the hydrogen is 0. So it is also called the standard hydrogen electron, which will be compared to other elements since it has the 0 quantity. So now we're going to have another half reaction. So now let us compare copper and zinc. First, copper gaining electron, turning into copper, solid copper has the standard reduction potential of 0.34, while zinc gaining electron, turning into a solid zinc, has a negative 0.76 standard reduction potential. So in determining the reduction half reaction, you will need to see the positivity of the standard reduction potential. So, which is more positive, the copper or the zinc? So, it is zinc. It is the copper. The standard reduction potential of copper is more positive than zinc because copper has a positive 0.34 volts, which is the standard reduction potential. So that's how you determine the reduction half reaction. So in comparing two elements in standard reduction potential, you will need to put the reduction half reaction. So in this case, in this table, this is the reduction half reaction. So let us compare the two elements. So as what I've said, the reduction half reaction of these two elements is the copper. So let us write the reduction half reaction of the copper. Which is gaining an electron, turning into solid silver. So the standard reduction potential of the solid silver is 0.34 volts. So we all know that in redox reaction, when something is reducted, there's always oxidation. So in this case, we have the zinc as the oxidant. So let us write zinc out. But first, this table represents the reduction half reaction. So how do we do the oxidation half reaction? So basically it's just making the solid zinc into losing of electrons, since oxidation is the losing of electrons. It's the exact opposite of reduction half reaction. So in the left side, you need to put zinc, solid zinc in the left side, losing electrons, which is the and now what the standard reduction potential of zinc is negative 0.76. Since we already have the reduction half reaction, which is the copper, and the oxidation, which is the zinc, solid zinc, now let us compare these two elements. Oxidation. So the copper here is gaining electron while the zinc is reducing the electron. So to get the cell reaction, you need to cancel out the electron, and then you need to put this, and then the other side, which is the solid silver and the zinc. Cell reaction. Two plus the solid zinc turning into copper. Solid copper plus the zinc 2 plus. Now this is the cell reaction. To get the total amount of the reduction and oxidation, or the overall, you just need to minus them. So the equation of the cell reaction is equals to the standard reaction or standard reduction potential of reduction minus the standard reduction potential of oxidation. So we've already determined where is the reduction and the oxidation. The reduction in here is the copper and the oxidation here is the zinc. So the standard reduction potential of the copper is 0.34, which is positive, minus the oxidation, which is the standard reduction potential of zinc, which is negative 0.76. The total of this standard reduction potential of the cell of the cell reaction is
3.
so since these two the total of this is 110 volts positive. So that is the total amount of standard reduction potential of the cell reaction in which the reduction half reaction is copper gaining electrons and the oxidant, which is zinc, losing the electron. So that's all. Thank you.